Okay, class, today we are going to continue talking about circumference and diameter, but we're bringing that math over to the science portion. We've been learning about the planets of our solar system. How many planets are there? Can somebody tell me? Go ahead, please. Thank you, Zadie. Yes, 8 planets. 8 planets. What's the smallest planet? Go ahead, Liliana. Mercury, okay. And what's the largest planet? Jupiter. All right, Jupiter. So we know the smallest. We know there are 8 of them. The largest is Jupiter. So today we're going to be looking at the circumference of those planets. Now we have the circumference or the diameter of the planets written in here, but let's go over some of our vocab words that we're going to be dealing with. So diameter, we already know that the diameter of a circle is a line that goes from one side of the circle to the other and goes through what? The center point. The center point. And just as a review again, what is a line that goes from an edge of the circle over to another edge of the circle, but does not go through the center point? Does anybody remember what that is called? It was in our measuring planets paper that we turned in. You had the different planets. You had to use a ruler and measure them out. Nobody? Okay. Called a chord. That's called a chord. And a line that just goes from the center of the circle to the side, doesn't go all the way through to the other side of the circle. What is that called? Yes, sir.
Thank you, Mr. Poulos. Radius?
Radius, absolutely. Very nicely done. Okay, so we now know what our diameter and our radius is. Circumference. Circumference is the outside of the circle, or that's what the perimeter of a circle is. Perimeter of a square is the 4 sides total together, but there are no sides on a circle. So we have the distance around the circle. Now we're going to also talk about percentages, because we're going to look at the percentage of the size of a planet compared to Jupiter, our largest planet, and that's comparing it to 100. Remember, cent is 100, century is 100 years. Okay, so cent is per cent per 100. And then a planet is a large object that orbits the sun, and Jupiter again is our largest planet. So we're going to go into how to figure out the percentage of how big a planet is compared to Jupiter. Now remember, when figuring out percentages, you take the part over the whole. So you take the object you need that you are going to be comparing to the object that you have. So we're going to be comparing to Jupiter. So that's the whole, that's the main part, the whole. And you put the other planet on top and you find out the percentage of that. Now, in the other part where we go for the circumference, when we go for the circumference of the planets, we are going to use 3.14, which is what? It's pi, but 3.14. Does anyone know what 3.14 is? It's a ratio. It is the ratio of the diameter to the circumference of a circle. If you know the diameter, regardless of the diameter of the circle, and you multiply it by that, you are going to get the circumference of the circle. Review point. What is the last digit in pi? When you work pi out, what is the last digit of pi? Say.
There is none.
There is none. Absolutely. Pi goes on and on and on. They have supercomputers that are calculating pi as we speak. It never ends. It keeps getting more and more finite, but it never ends because the circle, there's no ending point. So let's go on with our paper. So if you look at your paper, we have, close it the wrong thing. We have the diameters on the second page, planet diameter data. So we're going to take the smallest planet, Mercury. All right, Mercury has a diameter of what? How many kilometers? Somebody tell me. Go ahead, Reyes.
4,879.
Okay, so Mercury is 4,879. And we're going to compare that to Jupiter. So what is Jupiter's diameter? Kyle.
Thank you, Mr. Fuller. It is, 139,820.
820.
Oh, yeah, 820.
So if we divide Mercury's diameter by Jupiter's diameter, we're going to get a number. And whatever number that is, if we multiply that by 100, you move the decimal point 2 places to the right, and you're going to end up with a percent. So can I get one person from each table? Can you go up and grab several of the calculators, and let's hand those out to the students. So you can use calculators. If you have a calculator, you can use it. So yes. I only wanted a couple calculators per table, so just have a couple.
Yeah.
All right, you have one there, you have one there, good. Good, that's okay, you can have another one. They have two up here, we're good. Okay, you have a calculator? Okay, you can, oh, there you go. All right, so share the calculators. All right, so let's look at our formula that we're going to use. We're going to take Mercury's diameter, the planet diameter, we're going to divide it by Jupiter, and then multiply it by 100 to get our percentage. Okay, so let's look here. 4,879 divided by 139,820. Could somebody please tell me the answer you get? Who wants to give me the answer? Waiting for you, someone to get the answer. Liliana.
0.0348948.
0.034
8948.
8948. And that is a very, very small number. But we need to multiply it by 100 to get our percentage. We multiply any number by 100, we move the decimal point 2 places to the right for those 2 zeros, right? So we're going to go 1, 2. So Mercury is 3.4, and we're going to round it to the hundreds, folks. Is 3.49% of Jupiter. So if you think of that, here's this big planet Jupiter, and little Mercury is only 3% of that. That's the size of it. You would have to stack, if you had Jupiter, you would have to stack a little less than 33 Mercuries on top of each other, their diameter, to equal the diameter of Jupiter. That's how large Jupiter is. You'd have to stack 33. You go from one end of the diameter to the other. That's pretty big, huh? So now let's look at something a little closer in size. So I want everyone to work the problem on this page. I would like, or on the other page where we have the page 4. I want you to do Saturn. I want you to use your calculators, or even better, do it with division, long division, but I want you to give me the percentage of Saturn. Saturn's diameter is 116,460. So I have it set up in working form up there. Okay. So it's this right here. That divided by that, and then divide by 100, it should be down, but is your calculator not working? Okay. It goes back on the desk. So if you turn the thing and go to. You kind of start to move. Fast. Okay. So with your calculator, you should have put in 116,460. That is the diameter of Saturn. Divided by 139,820. Now doing it long division, 1.3 going into, I'm gonna say, I guess 8. Let's go 7. Let's try 7. 0, 14, 6, 7, 5, 16, 3, 16, 8, 6, 127, 2, 9, 0, 6, 8, 5, 8. Nope, I put it down 8. So it's going to be 80%, 80 something percent. What answer did somebody get? Yes.
Ambiguous pools 83.2928%.
83.29. 83.29%. So it's close. It's 80% of it. All right. So if we had Jupiter, Saturn would be probably right about there, maybe a little bit bigger. But don't forget, Saturn has those visual rings that you can see. Does Jupiter have rings?
Yes, sir.
Yes, it does. They're faint, but Jupiter has rings. What other planets have rings? Yes, ma'am.
Neptune.
And? Yes, ma'am. Uranus. I know you were trying to, it's a difficult one to say without making it sound dirty. Yes. But, so we have 4 ringed planets. What are those 4 ringed planets called? Do you remember what kind of planets they are? Yes, ma'am.
Gas planet.
Gas giants, or, go ahead.
Ice giant.
not ice giants. Starts with a J. Word starts with a J. You think you have it? You think you have it? Go ahead.
The Jovian planets.
Did you have that? You had Jovian? All right. I'll give you both credit on that. Jovian planets. What are the four inner planets known as? Yes.
Thank you, Mr. Poulos, terrestrial planet.
Terrestrial planets. Yes. All right. Big bonus. Who can name them in order? Looking for somebody who has not raised their hand yet. Give her some from closest to the sun to the furthest out. Looking for somebody who hasn't raised their hand yet. Yes. Go ahead.
Mercury, Venus, Earth, Mars, Jupiter, Saturn, Neptune.
You were close. You were close. Enough. Okay. Yes or no? All those think she got it right, raise your hands. Okay, all those that think she got it wrong, raise your hands. I think she's right. All right, excellent, good job. And how many of them can we see from Earth? Well, with the naked eye, you can definitely see 4 of them. You can see Venus. What is Venus known as? The morning star and the star. Okay, we can definitely see that. We can also see Jupiter. If it's so big, we can also see Saturn, and with a good pair of binoculars, you can even see the rings. Better if you have a telescope. And we can also see Mars. And when you see Mars, it actually has a red hue to it, as it's known as the red planet. And why is it red?
Because of the dot.
Why is it red?
It has a red tint.
Yeah, but what is the red tint? Somebody said over here. Go ahead.
The iron in the soil polymers.
The iron in the soil. It's red. Very nicely done. Very nicely done. So we know how we can calculate, and you'll be doing this page to calculate. But now let's calculate what is the diameter or the circumference of all the planets. So the first one we're going to do is we're going to do Earth. Because I want to know, if I wanted to go from this point on Earth and I wanted to do the entire circumference of Earth, and I want to walk around the planet, how far would I have to walk? Okay, it's not just down to the corner and back. I mean, it's going to be a long walk. So if you turn to independent practice A, what we are going to do, and let's get to our next screen here. Remember that circumference equals pi times the diameter. Does everyone understand that?
Yes,
sir. And pi is what? We're going to use the 3 digits pi. What is that? Go ahead. 3.14. Now the question, what is the diameter? Earth diameter, what does that equal? So what is Earth's diameter? In kilometers. Yes, Azina. Exactly, 12,472 kilometers. That's how far it is. So it is 12,742 kilometers. So now how do we write the formula to figure out how large the circumference is? Go ahead, sir.
Thank you, Mr. Poulos. You multiply that by 3.1.
Exactly. Putting it in working form, we're going to go 12,742 times 3. Did that wrong? 3.14. Did everyone see that? Okay, figure that out and tell me how far would I have to walk all the way around the Earth in kilometers? Your game board? Nice. Oh, it's yours? Oh, I like it. Use that, very clever monopoly set, years and years and years. All right. So in your calculator, type 12742 times 3.14. I'm gonna do it long division. It's not that hard to do. 4 times 2 is 8. 4 times 4 is 16, carry the 1. 4 times 8 is 28, plus 1 is 29. 4 times 2 is 8, plus 2 is 10. 4 times 1 is 4, plus 1 is 5. And then 2, 4, 7, 2, 1. 3 times 2 is 6. 12, 21, 22. 2, 6 plus 2 is 8. And 3. 8, 8. 19, 10, 10, 10, 4. How many now? Is it 4,988,000? What do I have to do? Go ahead, Bella. You have to take into account the 2 decimals. I have 2 decimals here, so I have to take the decimal here and move it in. And then the answer. Did you all come up with 40,009.88 miles?
Yes.
Hey, I remembered how to do math. And as you know, I've made quite a few mistakes. I would like to take this moment to thank Mr. George Shadrodian, my 9th and 10th and 11th grade algebra teacher. I took algebra a lot. Not different levels, unfortunately. I had to repeat the course a couple times. Yeah, it was bad. It was bad. Okay. Had other things on my mind. All right, so now we know that the circumference. So I would need to walk 40,000 kilometers to walk all the way around the Earth. That is a long ways. All right, I'm going to have you do 2 more. How short of a walk would I have to do to walk around Mercury? And how many kilometers would I have to walk to go around Jupiter? Supposing, thinking that I could actually survive on that planet. So, figure out the circumference of Jupiter and the circumference of Mercury. Using your calculators, it's okay. And the numbers are right there. Couple more minutes. Mercury. This one. Jupiter. X. It looks as though I'm gonna be very, very tired. I'm gonna be very tired walking around Jupiter. That might take me more than a couple hours to go around. All right. Mercury. 4,879 kilometer diameter. What is the circumference of Mercury? I'd like somebody who has not raised their hand to participate and raise their hand, please. Yes, Darrington.
Thank you, Mr. Poulos. 4,879.
Well, that's the diameter. What is the circumference? Take that and multiply it by 3.14. Can you do that?
Thank you, Mr. Poulos. One, I'm sorry, 1415430.06.
145. 154. All right. Could somebody read me the answer? How many kilometers is the circumference of Mercury? Go ahead.
15320.06.
15320.
And yes, sir.
Is that right?
Yes, sir. Yes.
Okay. 15,320 point what? 06. All right. So 15,000 kilometers. The Earth was what? The Earth was what? 20 some kilometers? 22?
4.4.
Okay. Kilometers. All right. So that's still a pretty sizable walk. But how about Jupiter? Who wants to give me the answer for Jupiter? Melody, go ahead and give it to me. Come on. Hold on. 437. Point four. So 437,904.4. Everyone get an answer close to that? Anybody get something different? Okay, what did you get, sir?
We got 43903. Oh, wait, 34.8.
439,034.8. Okay, I'm gonna be tired. That is a long, long distance. Okay. So what you're gonna do is you're gonna spend the rest of the period filling out these graphs. You're gonna be doing the circumference of the planets, and then you're going to be doing the compare the planets percentage wise, and then I want you to look at find the diameter from the circumference. I got taught in yesterday's lesson, you can take the circumference. So if I have a circumference of 600, or I have a circumference of 6.28. Okay. And I know that pi is equal to 3.14. We're looking for delta. We're looking for the diameter. We have the circumference. So we're going to use that algebra trick. What is happening to the D here? Class, what's happening to the D? By? What's the opposite of multiplication? Division. So I'm going to divide by pi. Anything I do to one side?
You do to the other.
Divide by pi. This cancels out. So now we have the formula circumference divided by pi equals diameter. So if I have a circumference of 6.26 and I divide that by pi equals diameter. And that's how I would find the diameter of an object that has a circumference of 6.28. not 2.6, 2.8. Wait, why did I wanna make it 2.8? Because it's easy. That divided by that is 2. So we'll do that one. When you're done, I want you to fill out one on the back page. I want you to do some critical thinking. You're gonna answer, why is Jupiter called a giant planet? Which planet surprised you the most when comparing their size? Why do scientists, I want you to think about this. Why do scientists use math to study space? And then do your synthesis of learning. I want you to tell me something that you learned today. And I want you to tell me something that's useful about percentages. And then there's an over-the-top problem. It gives you a mythical planet. You can name the planet whatever you want. And you're gonna find out what the diameter of that planet is and what percentage of Jupiter's size the new planet is. Okay? Questions? No questions? All right. We're walking around and helping if you need, but please get to work on that. Thank you.